Hi, my name is Stephen Ngbo. I'm here to present the lectures on the topic called frequency control. Frequency control. In the first place, let us find out what is actually frequency before we talk of frequency control. What is frequency? Frequency at the local level, or commonly can be said to be an event per time, happening of an event per time. That is the number of times something happens per time is called frequency. Let's assume if children get to school uh, 7 times uh, in a month, so the frequency of going to that school, uh, the number of time of going to that school in a month is called a frequency. Always assume if your wife cook pounded yam 3 times in a week, that is the frequency. That is the number of happenings. The number of events per time is called frequency. But we are talking of, we want to talk about electrical frequency and how the frequency can be controlled. So in electrical frequency is the number of oscillations per time, which is called hertz. Let's assume an armature is rotating in between magnetic field of north and south pole, and if it revolve 3,000 times revolution, 3,000 times per minute, then it is 3,000 divided by 60 seconds, which will give you 50 hertz, and that's the revolutions. That is called frequency. So the number of times a conductor cuts magnetic field in order to generate electricity per second, and in between the magnetic field of north and south poles, that is called a frequency. So, and what is the importance of the frequency before we even talk of controlling it? So, in the electrical power industry, the two main parameters are frequency and voltage. So, if you have a good generation with a good frequency and good voltage level, then definitely you will be delivering a quality power to the industry and the consumers, and they will be able to use it effectively. So what normally result to frequency control is imbalance between the load demand on the grid system and the generation requirements. So if what is generated at the generating station is not enough uh, compared to the demand, then definitely the frequency will begin to fall. And if the frequency begin to fall and it is not controlled, it could lead to total power collapse. So for you to maintain the system grid security and to deliver quality power, then you need to control the frequency. So if the load demand, as I've said earlier, is more than, is increasing, and it has exceeded the generation, definitely the frequency will drop, and we need to control it. So, and then what are the means of controlling the frequency? So the frequency control can be broken into three categories. The first category is called a primary control, then secondary control, and the tertiary control. So, and what do they mean? It means that when the frequency is varying, is going down as a result of high demand on the system grid, definitely it needs to be controlled. It needs to be restored back to the nominal value. And the nominal value, as far as this country is concerned, as Nigeria, is 50 hertz. And the statutory value is plus or minus 1% of the 50 hertz. Then the operational value is plus or minus 50 plus or minus 0.4. These are the values. So we have the lower and the upper. So the variation is between the lower and the upper level, which is the normal set values for the variations. So if the set values is so much exceeded, then we definitely, and it is not controlled in time, it will lead to system collapse or partial collapse or total collapse. So as I've said earlier, the primary control of the frequency, it is the initial response to the frequency changes, and it can be done from 0 to 10 seconds and can be sustained for about 20 minutes. That is primary control, and that is achieved by using governor controls. That's automatically governor controls, and governing control is an auxiliary equipment for the hydro generators that is able to regulate the speed of the rotor. So when the speed of the rotor is being regulated, it keeps the frequency within the statutory values. So then the secondary aspect, is that when the primary control is in place, is going on to replace the losses as a result of a loss of a generator from one of the generating station, then that one will come up to supplement for the primary control, because the primary control is now giving out its own extra load from the unloaded hydro generators, because they will not partially loaded. They are partially loaded. They are not fully loaded, but partially loaded. So by the time we have loss of generation, then those ones will begin to come up. The governor control will begin to change the speed of the rotor, and then it will come up, replacing the losses from the generation that have collapsed. So then the tertiary control is that one that the system control, that's from NCC and whatever, will be calling other generating stations now to bring in their own reserves. So we could have spinning reserves, that is unloaded generations that are already running in the same synchronism with the system grid that has been interconnected and has been synchronized. So when there's loss of generation, then call will be made, and that is manual. Call will be made to those stations that are already having spinning reserves. So then those ones will now come in with their own support and switch on the generators to bring in more load that will support the one that has been lost. So that is our system about frequency control. Can be controlled by using the governor control. It can be used, it can be achieved by bringing in spinning reserves. And most of the time, since if the generations, if the controls from the governor is not effective enough, and it's not effective to the spinning reserve, if they are not available, then we definitely have to go by local load shedding. Local load shedding, you tell the local loads to drop, the local control rooms to start opening feeders and dropping the load instead of bringing in the governor that controls the rotor speed and increase the generation. Then you can now ask them to ask the district or ask some of the transmitting station to start dropping their load so as to improve the frequency. And sometimes it is done through using under frequencies, where some loaded feeders are connected to under frequencies. So when the frequency is going below, we have stage 1 and stage 2, and most especially in ours here, we have stage 1, which is 49.01, and stage 2, which is 48.7. And some of the regions are connected. Some of the regional feeders are connected on step 2, and some are connected on step 1. So that when the frequency is varying beyond control, then the under frequency trips off immediately and reduce those loads to ensure that the frequency is returned back to normal. So this is the little that we can talk about the frequency control. It is done as a result of imbalances between the load demand and generation requirement. And if that is not done, then the security of the grid will not be sustained. So we can end up losing supply completely due to a lack of control of the frequency. It can be done manually, it can be done automatically, but when the automatically first, then mostly we go by manual, by telling the operators that are controlling some feeders, loaded feeders, to shut them down on the frequency control. You open them to reduce the load so that the frequency can be maintained within the regulatory variations. So thank you very much. This is what we can deliver for now. With time, we will talk more on the details of the governor control. Then we'll talk in details of the spinning results. Thank you so much for watching. Till we meet next time, and bye for now.